Hello and welcome to this video about containers. Containers is a more complicated type than the atomic variables. They're sort of, it's in the name, containers for the atomic types. So you can also have containers in containers, but the most simple ones, then you just have atomic types in containers. So they're basically storage objects. I'll show you some of them, but the idea is just that you can have multiple variables in one variable in a sort of an ordered way. They're also sometimes called collection types, if you run into that. There are many types of containers. Today we'll be looking at lists, tuples, and dictionaries. Pandas data frames, which is the normal way to work with data in Python, is also a type of container. So let's just get started. Lists is sort of a list of elements where each element can be different. It can be different types. Here is an example: is x is equal to a list, and you can sort of initialize them with the square brackets, and then each element is separated by a comma. So the first element of this list is the integer 1, and the second element is the string ABC. And then if you try to create this, then you see if you print it, then it prints the whole list, and the type is a list. A list has a length, which is basically just how many elements are on the list. So the number of elements in X is 2, because you have sort of 2 different things in the list. You can also, the smart thing about containers is that you can sort of have this one X, which you now have multiple elements inside of. And then you can take out the elements that you want to look at when you want to look at them. This is done using indexing. So you have X, and then you have these square brackets afterwards, and then you say I want to take index 0, the element with the index 0, out of the list. Thing about Python is that you count starting from 0. So 0 is the first element, and index 1 is the second element. People can have big arguments about this. Other programming language have one. You sort of get used to it when you've done it. I have no strong priors, but some people have really strong priors about what's the correct thing to have. But in Python we have from 0. So you can see here that if I say X and then have these square brackets behind, then I say I want to take the 0 or index 0 element, the first element out, and then you print 1, and then if you take 1 instead, index 1, then you print ABC, which are the elements in X that we defined here up here. So it seems to be working. Yes, and now we get to a new word, mutable. A list is mutable, which basically means you can change the elements inside of it. You can also change how many elements there are. But you still have the same reference for the list, but the references to the elements inside can change. So you can see that when you print here, then X has the same reference, sort of the same place in memory, but you have actually changed X. So what's happening here is that first we define a new X basically by changing the 2 elements inside of X. So now you can see here, if I just code it out, that X will now have DEF as the first element and 2 as the second element. Then we print the reference it has in memory, and see that it's this huge number, and then we change X, or change one of the elements in X, namely the second element, and we can see that it has the same reference. And yeah, as I said, you can also add new elements to X. So you can use this append method. So this basically just adds new element as an extra element at the end of the list. Yeah. You can also, here is a link to the founder of Python, who wrote a strongly worded blog post about why 0 should be the first index. You can read that if you're interested. You can slice a list, which is what you want to do if you want to extract multiple elements of the list, and then it comes out as a new list. So here we create a rather long list, which are the numbers from 0 to 5. And then slicing is done by still the squared brackets, but now you have a first index, and then a colon, and then a second index. And it's inclusive on the left side, but not inclusive on the right side. So what you get here from the first element to and this would be the fourth element actually, because you have 0, 1, 2, 3, 4, but it's still 3, so it's the same number. But you only get the first 3 elements because it's not inclusive on the right side. So this is what pops out here, the first 3 elements. You can also change the number where you're starting. So now we're starting from the index 1 element, the second element. So you only get 1, 2. You can also, if you have no number on either end, then it's sort of saying, I want everything to the left of this. So you just get the same as the first one. And here you get from the second element, the index 1 element, everything to the right of it. Python does this thing where even though we have a list here which has only length 6, if you say I want to get from the 99th element, which does not exist because the list is not that long, then it just returns all the elements that are available. This is not true for most programming languages. And it's probably not something you want to utilize in your code, but you should be aware that it can happen when you're debugging. You can also use negative numbers when indexing the list. -1 is the last element, -2 is the second last, and so on. So here you are taking the index from the last number, and then you're saying I want everything to the left of it. And because it's not inclusive on the right side, then you don't get the last number, but you get all the numbers to the left of the last number. And if you use these slices, then you get a list out because you have multiple elements. So Python stores that in a list and gives it to you that way. But if you only reference one element, then you get the type that element is. See here, this prints these two types. And this is just what I said. Slicing, and this is one of the nice thing about zero indexing and these have open intervals is sort of that if you have an I and you want the next n element, then you say from I to I plus n. This is easier to understand when you see actually loops that does these sort of things, when you see it working. And this is just another example. You can sort of utilize the fact that it's inclusive on the left side and on the right side. So if you want to slice something up, then you can use the same number and then sort of continue. So these are all the elements in the list, but not with no duplicates. Yeah. Okay. Now we have a question. Alright, so you are given a list X with the numbers from 0 to 5, and then you are asked what is the result of X if we slice it from -4 to -2. So I'll give you a quick hint that you have to sort of remember what I said about -1 up here. And I think I would like you to try to answer it first without coding, and then if you can't answer it with coding, then try to print x of -4 to -2. Pause the video now if you need to. Yes. Now hopefully you at least try to answer the question. Now I want to explain why we get what we get. -2. Is this right? Yeah. So the index you get from -4 is the fourth last element. So you can sort of count backwards. This is -1, this is -2, this is -3, this is -4. So you're basically saying from the index that is here to the index that is here, because this was -2. So this is sort of the same as writing 0, 1, 2 to 4. And because it's not inclusive on the right hand side, then you only get these 2 elements in the middle. Cool. Container types including lists are non-atomic. Yeah, this is again about referencing, and the IDs sort of that if you copy something, it will have, or not copy. If you set something equal, if you set a list equal to another list, then it will have the same ID. This sort of goes back to the fact that if you change the list, it also has the same ID. It's sort of they're more flexible without changing the actual reference. And another thing is that because they have the same reference, then when you do this, set y equals to x, then when you change y, you also change x, which can sort of cause a lot of errors, but it can also be really smart if you know how to use it, which you will know later in the course. But it's important to know. And then there's this is operator, which is another Boolean operator, which lets you know not whether or not the elements in the list are identical, but whether or not 2 variables contain the same reference. And of course, if they contain the same reference, the elements will be identical, but just because the elements are identical does not mean they contain the same reference. So here we print that y is x, which is true because we defined it this way, but sort of the counterexample is to create 2 new lists which are identical with regards to the elements, but because they're defined separately, then they are not, they don't have the same reference. So the is operator returns that it's false. Yeah, so that's the equal sign is a copy of the reference, not of the content. But of course, if you copy the reference, you copy the content. Yeah, and then this is sort of a counter to atomic types, which you've seen in another video, that cannot be changed without changing the reference. So you can see here that if you define it, w, the atomic type set as equals w, then it's the same. But if you don't change set, then there will not be the same reference because you're sort of overriding the set here. The reference of set is also changing when you add 5 to it. This was the augmentation operator. So this is the same as setting set is equal to set plus 5. So plus equal. Yes, and if you, now we still have the x's, which are the same list, with the same reference. And if you delete x, then you don't delete y. You still have y left over. If you want to make a copy of the values or the elements in a list, but don't want to have this sort of this reference things to worry about, then you can use the module copy you just say from copy import copy. Sort of annoying syntax, but annoying writing, but that's how it is. And then you say copy of x. Then y gets all the elements of x, but if you change y, you no longer change x, which is what you can see here. Yeah, so you can see that y has this change that we made, but x does not, and x is not y, because they're not the same reference. It's just a copy. Yeah, and you can also do this without importing the copy module if you use slicing. Sort of if you just put the colon in the middle without any indexes on either side, then you're saying I want everything to the left and everything to the right, so you're saying I want everything. But because you're doing a slice, then it's a copy and not a reference. So this is what you get here. You get basically the same. And it would also be the same if y was only a slice of x, then it would also not have the same reference. Yeah, this is a bit extra thing. You can have, as I said at the beginning, you don't necessarily only have atomic types inside your containers. Sometimes you have other containers inside your containers. So here's an example where we have a list inside a list. So you have A, which is a list, and put it as the first element in X, which is also a list with the other elements. And the issue you can run into here is that if you use the copy operator, then A still has the same reference. So the A that is side of X has the same reference as the A that is side of Y1, but only inside of Y1. Then you can use the deep copy to get out that problem, to say, okay, I want everything to be just the values of the elements, but not the references. So it's sort of this is the example here. So you create this X, which is a list with the A inside of it. Then you create Y1, which is copy, and Y2 is this deep copy. And then you change A, and you change X directly. And if you print X, then both changes will sort of have occurred. So this is the A list, and you change the first element to 10, and the last element of the X list is changed to 1. In the copy, you have that you don't have the change in the direct change to X, so you have the original value of 3, but A has changed because A had the same reference as the one in X. While for the deep copy there are no changes. So this is the original list. Oops, and now we have another question. To the following code, you have X a list and Y is a list with two lists as its elements. And then we define set as being equal to X, and then we change set. And then you asked, what's the result of print y of 0? So yeah, try to pause the video and see if you can answer that. Yes, okay. So let's print out the answer. So this was very much related to the reference stuff. And here you sort of make no copies and no slices. So set has the same reference as same references as y and x. Or maybe I should explain a little better. You define set as being equal to x. So set and x has the same reference, and y contains the references of x. So when you're changing set, you're also changing x. So you're also changing I. So the first element of y, which is this x, this will be the changed x. So it has 3 as its first element, 3 as its first element, and 1 as its last element, and 2 will still be the middle element. Yeah, that's the answer. And it's sort of, it's important to remember that these sort of things crop up. Like in a lot of code you'll be doing in the beginning, you will try not to rely on this sort of stuff because it can get sort of complicated. But sometimes you make an error where you accidentally rely on it, and something pops up where it doesn't supposed to be, or you change something that you're not supposed to change, and then it's good to know what these sort of things does. Tuples is one way of working around these kind of things. A tuple is the same as a list, but it's just what's called immutable, which basically means that it can't be changed. They're created with the round parentheses, and they are indexed. The elements are indexed by brackets in the same way, and you can use slices in the same way. And yeah, as I said, you can't change them, and you can't change the elements inside of them. And this is sort of, they can be used to pass in variables that should not be changed by accident, to sort of get around this reference issue. Sometimes you actually use tuples without really thinking about it, because they'll be outputted from functions, and you'll unpack them. You'll see that in, when you learn about functions. But it can be sort of, you should be aware that sometimes you're working with tuples without thinking about it. And yeah, and you can use tuples as arguments to a function. So it's not really. You can use all variables as arguments to a function. Yeah. So to create a tuple, then you just use normal round brackets. One thing you should note is that this will not create a tuple, while this will create a list. That's because the round brackets are also used for a bunch of other stuff, like multiplication, stuff like that. So if you want to create a tuple with one element, which you rarely do, but if you want to do it, then you just place a comma here at the end. Let's get back to our longer tuple of 1, 2, 3, and then we sort of run this code. Then you can see that the printout is what we have defined it as. The class is a tuple. And you reference it the same as the list, and if you slice it, then it returns as a tuple, a smaller tuple. Yes, and this is just to prove to you, and sort of you can see how the code works, that it is immutable. So we use this try command, and then we say, okay, try to set x, which is our tuple, set the first element of x to 2. And then you print, okay, I could do it. And if you can't do it, then just print, I could not do it. Then you can see, okay, it did not succeed. And we can see that the tuple is still the same. The first element has not become 2. Yeah. So now a third kind of container is called a dictionary. And it's key based. So it's sort of tuples and lists are sort of based on the order of the elements, and you say, okay, I want the first element or the third element, or maybe you're looping through all of them, but like if you want a specific element, then you have to have the order of the element. While dictionaries, they don't care about order, and it doesn't happen, but you shouldn't rely on it, is that it can change the order after you define it, because it's like doesn't care about the order, but it does care about keys, which can be anything, but we'll start out having the keys as strings, and then you can say I want, I can start with the element that if you define it like this, then the key is here ABC, and then you want the ABC element, and then you always get this. If I said I want the first element, then I don't always get this, usually, but you can rely on it. And it can be very nice, these dictionaries, sort of when you want your data to not be reliant on an order, but you want it to be relying on a name or something. The typical example is a phone book, where you sort of, you don't want to say I want to have the phone number of the 5th person in my phone book. You want to have the person with a specific name. Yeah. And I think we will use it for a lot is be later in the course, but we'll use it. I think you use it for a lot is the values of parameters or variable in an economic model. So you're not saying the first element, the first parameter in our model. You're saying the beta parameter or the theta or something. Yeah. And dictionaries are sort of both immutable and mutable. They're mutable in the way that you can always add new elements, and the values are mutable, but the keys are immutable objects. So you can't change the key after you find it. Then you have to define a new element of the dictionary. That's luckily not that hard. Yeah, so let's look at this code. So we're defining a dictionary by using the curly brackets. We're using all the brackets today. And then you have the key, and then the value that key references, and then a colon between, another comma, and then you define a new pair of key and value. So this dictionary has 4 sort of elements or 4 key value pairs, and you extract the content again, or the elements again, or the values would probably be the correct word. You extract them with the squared brackets and then the key that you're referencing to. So this key referenced to 2.74. And you can also change so the values were mutable, and you can sort of change the values in the dictionary for a given key. And yeah, one thing, and this is also true for lists, but it's sort of very usable for dictionaries, is that the key can be another variable. So you can sort of, if you say key is equal to ABC, then you say x of key, then it will interpret it as x of ABC. So you get this 100, which we defined here. You can also use that when you want to find a list. So if we write a 1, 2, 3, and you say I want my index to be equal to 2, and then I want to print x of my index variable, then it will print the third element, because 2 and 0 indexing. Yes, but it's very, very usable when it comes to dictionaries. You can delete a content or value from a dictionary using the key. You still have redefined x. Yeah, so you still have the dictionary, but you delete one element, the first element in this particular example. Okay, now we have a bit of a longer task. You are asked to create a dictionary called capitals with the capital names of Denmark, Sweden, and Norway. So the country names are keys, and the capital names are values. If you can't remember the capitals, then that's okay to Google. And then yeah, try to do this. And yeah, pause the video now if you want to try to do this. Yeah, now I hope you were able to do it. We have the answer down here. If I double tap it, so you could do this multiple ways. The way it's done here is that you sort of predefine the dictionary as an empty dictionary, and then each name is filled in. So Denmark has Copenhagen, Sweden has Stockholm, Norway has Oslo, and you can sort of test if our answer was correct by saying, okay, the capital Sweden must be our capital dictionary, and extracting Sweden, and then we print it, and luckily it's Stockholm. You could also write it in the same way as I wrote up there, where you sort of write Denmark, Copenhagen, Sweden, Stockholm, and so on. That sort of preference, it gives the exact same answer. Yeah. And yeah, as a sort of a reference to the notebook about atomic types are immutable. And strings are actually subscriptable as lists, and you can slice them, but they're still immutable. So you can define a list here, and then you can slice it in the same way. So you just pretend that the first element of this string is A. Don't pretend, but it is. And B is the second element, C is the third element, D is the fourth, and fifth, and sixth. And then you can slice it and print it like this. So you can print the first 3 elements, and you can print from the fourth to the fifth, and from the 5 and on. But we have this try, and then you can say, okay, what if I just want to change the first elements? So I want to change this A into F. You can't do that. Then you have to create a new string. That's just how it works. The new central concepts are containers, which are lists, tubes, and dictionaries. So the words we've been using is mutable and immutable, so whether you can change something. Then we've been talking about slicing, when you want, if you have a list or a tuple and you want multiple elements from that list and tuple. And then we have talked a lot about this referencing, and you need to be aware that you're sort of sometimes referencing stuff, and your variables can change if you change something else, if it's a reference. Sometimes you want to do a copy. And then we talked about dictionaries and key value pairs. If your head is totally bummed out from this video, then you can just pause it now and come back another day. But I have a little extra stuff if you're interested, because there are many containers, and some of them are sometimes good to use. One of them is the ordered dict, which stands for ordered dictionary, which is sort of comes back to what I was talking about earlier, with dictionaries not being like ordered in the same way as lists, not as consistently, where you can sort of ensure that. There's a whole like list of collection. Sets is another type of variable or type of container, which can be really useful. The main thing I've used it for is to delete all duplicate values in a list, but there are also other benefits. Then there's another type of variable called a simple namespace, which is sometimes a really handy replacement for dictionaries. And sort of it has fewer capabilities, they can do less, but they offer shorter syntax. And that's their only benefit, but sort of it can get really nice if you're referencing something from a dictionary a lot. So they basically just replace, instead of this squared bracket and string, then you can just write x.abc. So yeah, I'll just quickly show you how it works. So you have to import a simple namespace type from the types module, and then you can create it from a dictionary. That's the easiest way to create it. I'm not saying it's easy, but if you understand dictionaries, then it's the easiest way to create it. You just have your dictionary, and then you unpack the dictionary into the simple namespace using double stars. You understand that when we have when you learn about functions. And then you can print I, and then it's a namespace. You could also just write it like this if you don't want to create a dictionary first. This does the same thing, where you just have each element you want, and then you say that's equal to this, that's equal to this. Yeah. So that's how you create it, and then you can reference it using this dot notation, which is, I mean, it's just simply quicker to write, and it looks a bit nicer. And you can see it gives out the same answers here, because we define it as being equal to I with regards to values. Yeah, as I said, the only reason you want to do this is sort of simpler syntax. And you can easily turn it back to a dictionary by using this attribute. So this is our simple namespace. Then we write dot underscore dict, dot underscore underscore, and then we get a dictionary out. Yeah, so that's it from this video about containers. I hope you learned something. Thank you for watching.